So my name is Joe McConnell. I'm with the Chief in Information and Digital Office at Northrop Grumman. And I'm about to introduce Randy. Right below, we've got our LinkedIn QR code. So if you want to talk to us, we'd really like to chat about this stuff later, or you can just find us. And so specifically, Randy and I work for our corporate organization. So we're going to be talking about our customers today. We're going to be talking about those employees and programs that work internally to Northrop Grumman. So those are the ones that may have built and designed some of the products you guys have heard about, right? Like our B-21 Raider. It's our stealth long-range strategic bomber, or our high-altitude long-endurance UAV, the Global Hawk. And so today what we're going to be sharing with you is about our Kubernetes journey. So hopefully, particularly for those of you that are getting started, I think you'll find this really interesting. We've sectioned this off into the different products that we've developed as we've kind of worked with our customers. And so we're going to be focusing on that. So working with your customers, how you can understand what they need. And what is likely going to come as a no surprise to anyone here in OpenShift Commons is that we decided to pick OpenShift, and we're going to talk about how our strategic relationship with Red Hat was really important to our success. So this is going to start back in 2020. You guys may remember this. For us, it was kind of the wild, wild west of Kubernetes. So we had programs in different environments, all these disparate people that were working on containerized apps, different Kubernetes, no connection at all, no standardizations, all types of flavors of Kubernetes. And really importantly for us, it was very difficult to secure and manage. So having all the correct tools, having all the standard configurations, that effort was just very difficult for us. And so we decided to fix this. We needed to start with a multi-tenant shared environment. We knew that it was going to be based on kind of a modern Kubernetes infrastructure. We knew it had to be multi-cloud. We were in AWS, Azure, and on-prem. Again, we knew it had to be secure. It had to be highly reliable. And as far as our customers, they were going to really want full self-service type of thing, right? They want things when they want. We're going to have to basically convince people to adopt our corporate option. So we knew that being really close to our customers, understanding what they were going to need, and building at confidence was going to be critical. And so we kind of first set our vision, right? We said, how are we going to choose which products and tools are going to be a part of this? And so we knew, again, it had to be highly available. And because we're corporate, it also had to have low costs. And for us, what that means is minimizing our labor requirements. So again, fully self-service. We're not going to pay people to wait and hit requests. We're going to do minimal support for our platform, right? So we're going to provide the platform. Our developers, our customers, right? They're going to do all the coding on top of that. We knew we wanted GitOps managed app release. That was going to allow us to minimize the permissions on our production cluster, but still allow our customers to develop and release very quickly. And just overall kind of minimize that customer service, right? We were hoping that our customers would jump on it and they would learn how to use this, so we didn't have to put a lot of toil into that type of work. We also had the idea of a centralized vulnerability management system, trying to help our developers very easily develop secure applications. And we also assumed that everyone would be super excited once this was available, and that all of our developers would be jumping on it, and therefore we were going to need to scale very quickly. And so, again, it's not a big surprise here, right? We picked OpenShift to be at the central part of our core infrastructure. And what we really liked is the whole suite of tools, right? We've seen lots of slides, all the different pictures of all the different open source projects that make a platform what it is. Red Hat was able to put that together for us in kind of this holistic approach that allows us to have that single platform that was going to work really well. We also have been working with Red Hat for many years. We're big Red Hat Enterprise Linux customers. So we had a lot of confidence that as we were learning Kubernetes, as we were learning all these new tools, that Red Hat was going to be there for us to help with our particular design architecture. And then later when we needed support, they were going to be available to us. Because again, as I mentioned, right, we want to minimize our labor costs. So we'd rather make a phone call than have one of our team members always have to fix something. And then also a big important part for us was that OpenShift integrated with a lot of tools that we already had in place. And so if we take a look at this a year later, right? So this was in 2021 after we'd done our initial install and deploy. We were successful, highly available. That worked out really well for us, fully self-service. Everything, all of our requests that our customers needed are available through an API. What didn't really work so well, right, to be kind of open, is that we needed to provide more developer support than expected. Our developers were not used to kind of managing their own environments. They weren't used to containerization. And so we had to help them, particularly get beyond that hello world phase. We also were successful, though, in our GitOps managed releases. That's really worked out very well for us. The minimal customer service did not work out. We've had to do a lot more hand-holding to get a lot of our teams up to speed on how to do some of these things. Also, our idea of a centralized vulnerability management systems didn't work out. We assumed we were going to be able to automate the process. We're going to pull from like Iron Bank, which is managed by the Air Force, or Red Hat. We assumed we could pull those, scan them, get a clean bill of health, and then just make those available. As many of you probably found out too, there's very few container images out there that don't have high and critical vulnerabilities. So instead, what we had to do was build another process that allowed these programs to scan the things themselves, and then they were able to adjudicate and remediate the vulnerabilities themselves. We also didn't find that the hordes of developers didn't show up as soon as this was available. But what we did find is those early adopters, they were very excited, and they were really great to work with because they were dedicated in helping us kind of make this a better product. Kind of wrap up our first shared Kubernetes platform product is that we found out is that you guys probably know Kubernetes is really hard. And so without us working with Red Hat, I don't think we really would have been able to get there. We also found that you can't put everything in Kubernetes, but your leadership wants you to. Every single time there's a problematic app, our leadership said, hey, can you just put it in a container for me? And our answer was no. Right? Particularly with COTS apps, if it wasn't built for a container, we weren't going to do that. We also found that our migrations, our modernization from our legacy products didn't happen like we had expected. Particularly in our corporate environment 5 years ago, we were very Microsoft heavy. We were using different versions of .NET, and more importantly, we were using Windows authentication. The problem with that was that modernizing to an authentication system that was going to work in a Kubernetes environment is pretty difficult. And so it wasn't really cost efficient for a lot of our teams to move over to a new authentication system. So instead, what we focused on was greenfield apps. So those are the new apps. They want to get something out quickly. They want all the new bells and whistles, right? We worked really well with them. We did find there was actually more COTS apps than we'd expected, particularly for a lot of our augmented reality, some of our machine learning stuff. A lot of these more modern apps are coming containerized, and we were really able to help our customers out there because they were just excited to have a new tool. We had the platform, we had the security all in place, so they were able to easily onboard. And then again, kind of those forward-leaning devs, they were just fun to work with, right? So we were able to really have a good time with them, learning new capabilities, and kind of growing this as we've gone.
So the COPS apps began to be more common. Apps like the Microsoft Copilot projects, IBM had several AI initiatives, and several of our augmented reality apps. They worked really well, but they had a problem. Most of them required kubadmin or admin level privileges. This was not something that we could allow in our shared tenancy clusters. And their timelines started becoming more and more tight. Our customers wanted clusters built and handed in hours. Typically, we were like, it takes weeks to build these things. They wanted them in hours. And then they began requiring Azure native services. And it's difficult. We're in a zero trust environment largely, and so firewall rules are challenging. And so to have resources or clusters in Azure started to become appealing. All of these things presented significant challenges for our team. So these challenges led us to look closely at Azure Red Hat OpenShift, the cluster as a service. This would be a significant change for our team, as we had typically, prior to that, just been running on Amazon. We would provide our customers dedicated clusters while leveraging the Microsoft Red Hat SRE teams. This support was critical as my team was getting stretched between maintaining legacy clusters and developing new solutions. And as Joe mentioned, helping our customer base that didn't really know a lot about Kubernetes. So using Arrow greatly increased our ability to automate cluster stand-up. It decreased our deployment time considerably and allowed us to deliver more consistent clusters. We were able to meet our cyber standards and requirements on day one. As a bonus, the licensing became much more simple. our licensing was based on our cloud monthly charges, not annual licensing. So to dive in a little bit, specifically what we did, we decided to use bash scripts, which would call Azure CLI. We wanted to use something that would be common no matter where we went, and since we were starting with Arrow, we wanted something that would work anywhere. So we initially started with that. It worked really well at first, but then we ran into problems. There were different versions of WSL on laptops, different versions of Azure CLI within the team, Bash, various other tools would often cause our installation methods to fail. So at this point, we developed a build container or a set of containers that allowed us to build these. Anytime we needed to create a cluster, we'd spin up our build containers, and those had the proper versions of our tools. And because they were based on Bash, they had fewer libraries, which kept our images small and easy to maintain. With this build container concept, we met our goals. We were able to deliver compliant, secure, and standard clusters, while also delivering all the platform services that our customers were expecting us to do. I wanted to touch on some of the lessons that we've learned as we went through this process of building on Microsoft Arrow. The biggest one is our initial expectations, I believe, were unrealistic. I still recall it was a Friday afternoon. We met with our Red Hat partners and our Microsoft partners, and our goal was to build our first cluster on Azure GovCloud. And our networks are special. They're very restrictive. So a lot of the services that are common, that everyone takes advantage of, they're prohibited for us. So needless to say, it did not go as well as planned. However, with the help of our Red Hat and Microsoft partners, we were eventually able to develop this, and we were able to develop an infrastructure as code process that we still use to this day, or leverage that foundation work from those days. It took quite a bit more work than we expected, but the end product was good, and our customers are very, very happy. The other aspect was the cluster support. Initially, it was difficult to understand where our responsibilities ended and the SRE team that was run by Red Hat and Microsoft began. But after a while, we worked that out, and our realization, we had a better understanding of what that looked like. The other goal that we did not achieve was to suspend Arrow clusters. We had a customer that wanted to save money, shut down their clusters or suspend them on the weekend. It was largely for development efforts. It turns out that you can scale worker nodes, which is very good for now. Now that we're starting to introduce GPU nodes, that becomes a critical factor. But the control plane nodes you cannot scale. And so we weren't able to achieve that goal. But even with that shortcoming, our customers have been extremely satisfied. We were able to deliver OpenShift clusters in about 3 hours, and that's all of the services on top of everything. And so we've exceeded customer expectations. They're entirely built as code at this point, which drastically has reduced our operational support burden. And I mentioned earlier, licensing is greatly simplified. So the next phase of our journey, this one has been much more recent, and it's been considerably more challenging. We've received a directive to build OpenShift clusters not only within the Azure cloud, but also in AWS, and also on-prem. So, and on top of that, these on-prem often will need to be disconnected environments. So with this directive, we've heavily used GitOps principles to automate our build processes. Regardless of the environment, they're using the same process to ensure consistency. We also received increased security requirements specifying NIST 853 standards and CMMC 2 compliance. And if this wasn't enough, we have to build our clusters in a way that new admins are enabled for success, and fully knowing that many of these new admins will have limited to no Kubernetes experience. So I want to dive into the mechanics of how we're doing this. The primary reason for our success was the foundation that we laid down with our early Arrow work, with our Microsoft and our Red Hat partners. Our build container has now expanded beyond just Arrow. We're now building on AWS and bare metal. We have some challenges with bare metal, but the AWS process is largely the same as the Arrow process, just different APIs. And that was easy because of our choice to use these build containers. So it was fairly seamless. The bare metal, on the other hand, is a little more tricky. For bare metal, we have to ensure the hardware's up, that we have the network and the storage components up in place. And then at that point, we have a vanilla CoreOS and vanilla OpenShift installed, and that's at layer 1. At layer 2, we use Argo CD to start building out our governance and our common capabilities. And the prior group, Morgan Stanley, I believe, mentioned they're using Flux. We're actually exploring Flux to make things a little more simple. But right now we're using Argo CD, and it's working really well. And then at the top stack, this is not all of our common capabilities that we lay down, but we have Grafana, Prometheus, and Loki for observability. We're using Keycloak for single sign-on and authentication, and then Ansible, and then we're laying down we're laying down Argo CD and Tecton for our CI/CD pipelines for our customers. We're also installing ACM and ACS. ACS is doing our governance and compliance and our vulnerability scanning. One of the biggest lessons we've learned in this effort was found in that layer 2 area on the previous slide. Early in our Arrow development, we had made a decision to use Red Hat validated patterns to provide Helm charts and GitOps to automate the installation of these governance and common capabilities. The code base we found was challenging. It was very difficult to manage. Often the upstream would change and it would break things that we were using. So even though we had put a significant amount of effort into that validated patterns, it was very good, and we'd put a lot of effort into it. We decided to pivot at that point and go strictly to Argo CD. It has proven to be a very good decision. Not only has it been easier to maintain, but also has provided a great pattern for our customers to use for their own workloads and application installs. An additional benefit to this is additional benefit to the standardized cluster build approach has been around our day 2 operational support. Because our clusters are all built using the same code base, we've been able to train one of our operations teams to maintain many of our day-to-day tasks, especially in the area of patching. And it's been very, very successful. This has given my team much more time to develop new solutions as opposed to the day-to-day operations. We've also documented this very, very thoroughly because as we go into our bare metal stages, we're going to be, sorry, I'm running out of time. But
it's all good, yeah. Yeah, so basically, with all of our documentation, right, we were able to pass those down. So as our admins, as we're handing you a Kubernetes, it's all nice and shiny. We're also going to give you some documentation and Grafana dashboards and all kinds of fun stuff to keep those up and going.
But yeah, the last.
And once you hit the next slide, so what we're really excited is about what we're going to do next, right? And so you guys have already seen some of those things. So dev spaces, for example, it's something that's kind of built into OpenShift, and so it's taking an investment we've already done all the work on, and it kind of expounds on that. OpenShift AI, you guys may have heard about that. It's going to be kind of a big deal, and so we're really excited. We're doing some hosting of LLMs, doing some cool kind of fine-tuning and training. HPC is going to be our next big thing. So like everyone here, if you were at GTC recently, right? Everybody has got to buy their new shiny NVIDIA on-prem GPU farms, all that kind of fun stuff. And so what we're doing with OpenShift AI is really going to help us take advantage of a lot of that hardware.
Joe, if I could jump in, we're cutting into questions a little bit, but we have a new VP, and it was he came to us a few months back, and he said, "I want a GPU farm by Christmas," and so
he showed up like 3 months ago.
And we delivered his GPU farm. We leveraged OpenShift AI. And I will point out that we made slide, I don't know what, before we mentioned AI. So.
Right, yeah.
Anyway, and the HPC farm, we're talking 30,000 cores. So this is going to be non-trivial. We're excited to look at managed control plane and other technologies to help us with this. But yeah, we're excited.
All right, yeah, and so again, definitely come ask a question, come find us later. Really excited to talk to anybody about doing any of these other new products. Thanks.
Thank you.
Two quick questions for you. The first one, you talk about off-the-shelf software. Migrating off-the-shelf software that's not meant for OpenShift is extremely difficult. Did you create a dedicated cluster for that, or did you work to identify the roles that need to be implemented so that they could work without kubeadmin?
So
Cluster admin.
I can take this one. So dedicated clusters.
Okay.
Typically, they require kubeadmin, so you can't share. We might have an augmented reality tool. We might have an AI tool. A lot of the Microsoft Copilot tools, they need that. SAP tools were some examples, but dedicated cluster.
Yeah, so that cluster as a service was really all about those COTS tools.
Yep.
Okay. Yeah, I was hoping that you guys who came up with an innovative solution. That is one of the biggest issues with customers. The second one is, have you looked at hosted control planes? Since you said you were going into bare metal, hosted control planes with virtualization?
We're very excited about those. We're talking to Red Hat, and some of our team is here. So yeah, we'll be looking at that very soon.
Okay. Yeah,
and then in particular, again, as we mentioned, like some of ours are disconnected or classified environments. So we're trying to figure out how do we manage all these different environments, especially when we can't touch them. So we'll see how that goes.
You mentioned ARO. Are you using ROSA, or are you just using regular AWS?
So regular AWS now, but our next step is ROSA. We actually want to put them on ROSA, the hosted control plane.
So because ROSA offers HCP.
Yeah.
Because we're a defense contractor, so we can't use like Azure commercial or AWS commercial. So we have to wait for them to kind of make some of those things available, specifically in GovCloud or in Azure Government. So it just takes us a little while to get up to speed sometimes.
Yeah, I work with Palantir on GovCloud. That's pretty difficult stuff. So
yeah.
Good work.
Yeah, this is a question on the on-prem. What kind of storage and what kind of network you are using?
Okay, so we're brand new to on-prem, and in fact, this GPU farm is our first on-prem cluster. We're using DDN storage and NVIDIA networking.
VDN.
Yeah.
And we're also working with Dell, in particular with our Future Tech group, to kind of create what we're calling a single SKU. So it'll have a standardized environment. So it'll have all the devices that we need. So it'll have the Dell servers, all the switching, as well as all the licensing, kind of in one little SKU, so we can pick those out, because we'll be deploying a bunch of these in different environments.
Okay, thank you.
And those will be all managed by different programs and things like that.
And one more question. You're using Azure, AWS, and on-prem. Why are you not using Terraform to integrate the whole thing?
We looked at Terraform, and there are some components. Our bash scripts are in code. They've been working really well. They're very simple. They really just call our build containers. So our build containers have been working. We have Ansible. We looked at using a lot of Ansible as well. It's just what we started with, and it's working really well, so we haven't fixed it. Or, I mean, maybe I shouldn't say fix it. It's working, it's not broke, so we're leaving it alone.
Thank you.
Yeah.
Hi, can you say more about how OpenShift AI fits into that Dell single SKU system for delivering that on-prem GPU farm? Is that something that Dell is kind of wrapping into?
Yeah, so we're actually doing a full, it's called Lighthouse, so with NVIDIA. And so they have kind of a partnership with different companies. And so, yeah, they brought together Dell, NVIDIA, DDN, and Red Hat. And I think and then all kind of work together to do our initial GPU farm.
I will point out there's no way on earth we could have built that in 3 months without Red Hat. They were absolutely critical. DDN and NVIDIA were critical partners, but Red Hat was in the room, on call, 100. I mean, they were available. No way it could have been done in 3
We've been
months.
in the cloud for a while, so we weren't used to dealing with hardware. So sometimes hardware shows up broken, racks and stuff like that. We're used to software problems. So dealing with all that was interesting, but we're excited to kind of work in that space again.
Thank you.